students make two big mistakes when it comes to this question. Let's go ahead and read it. Here we have a differentiation with trigonometric question. The figure above shows the graph of the curve with the equation y is equals to 6 minus 4 sine theta minus cosine squared theta, where theta is in degrees between 0 to 360. The curve has a minimum at point A and a maximum at point B. Determine the coordinates of A and B. Let's mark this for later. So whenever we have to determine minimums, we're talking about points where the gradient is 0, meaning we're going to take differentiation and we're going to equal that to 0. So let's go ahead and do that. We have dy over d theta, not dx, because our other variable is theta. It's going to equal to, we're going to go one by one. For differentiation of 6, is going to be 0, it's going to go away. Then we have minus 4 sine theta. Sine theta is going to be cosine theta. That's in your formula sheet. Minus 4 cosine theta. Then we have minus cosine squared theta. Be very careful when you're doing trigonometry in general, especially when you're doing it with differentiation. The minus and plus sign can always make you confused. So if we put a minus, I put a bracket. Now we have a compound function here. We have something like f of x squared, where f of x is the cosine. How do we take derivative of that? We have to take first 2 f of x times f prime of x. So we're going to have 2 cosine theta times derivative of theta. Derivative of theta is minus sine theta. However, this is not plus minus, this is a multiplication. So don't think this is 2 cosine minus sine theta. No, 2 cosine sine theta, but with a minus. This is where students make very common mistakes. So we can now put this equal to 0. 0 is equals to minus 4 cosine theta. Minus times minus gives us plus 2 cosine theta sine theta. This is where we make the second mistake that's commonly seen, where students would naturally try to solve this, would bring this to the other side. 4 cosine theta is equals to 2 cosine theta sine theta. However, you cannot cancel these two. That is part of the solution. So cosine theta being equal to 0 is part of the solution and it cannot be simply cancelled. So what you can do instead, you can factorize it. We can factorize cosine theta and 2. So it's going to be 0 is equals to 2 cosine theta minus 2 plus sine theta. Given that it equals to 0, either one of these being equal to 0 will result in our solution. So let's look at this one. We're going to have sine theta is equals to 2. So sine inverse of theta of 2 gives us theta. Sine inverse of 2 does not exist as the function. The domain of this function is between 1 to minus 1 or minus 1 to 1. It cannot be below or above that. So our only answer is 2 cosine theta is equals to 0. We can just get rid of the 2. Cosine theta is equals to 0. So you should already know this, or you can put it in the calculator as well. The theta for cosine theta is equals to 0 is going to equal to 90 degrees or pi over 2. Here we want to keep it with degrees as the solution given is also in degrees. So this is one of them. Looking at the graph, it can easily be determined that this is A, the smaller one. We can get another solution from this, and that's by using the property of cosine. See, a cosine theta is equals to cosine minus theta. And for cosine and sine, you can add 360 to it. So what we can have is we can have 360 plus 90 or minus 90, as it gives the same result. And we're going to get 270 degrees. So that's going to be our two thetas. Theta 1, let's call it, and that's going to equal to theta 2. We are not done yet. This is the next problem, next mistake students do. It didn't tell us to find what theta are there. It told us to find the coordinate. So what we have to do is we have to find the y value as well. So for theta 1 is equals to 90 degrees, we have to put it into the function. Y is going to equal to 6 minus 4 sine 90 minus cosine squared of 90. You can put this into the calculator to not confuse yourself. However, you can be sure that sine 90 is going to equal to 0, and cosine 90 on the other hand is going to be 1. So once you do that, we get 6 minus 0 minus 1 squared, which is simply 1. You get y is equals to 5. So we get 90 degrees as x and our y value as 5. Now for theta 2, that's equals to 270 degrees. This one is best if you just put it in the calculator. Sine 270 degrees minus cosine squared of 270 degrees. Let's put in the calculator. Again, make sure you're in degrees. 4 sine 270 minus cosine 270 squared. And we get y is equals to 10. There we go. So this is point A, and point B is going to equal to 270 degrees and 10. That's all.